Hello and welcome to PyData Global 2025. I'd like to introduce Jacob Tomlinson, a good friend of the PyData community. If you've been to any of our conferences, you've probably seen or heard Jacob before, so we're so glad to have him here joining us for PyData Global. So anybody that is here with us, I'd love to encourage you to interact with one another, interact with Jacob in the chat, drop some questions. We'll have about 5 minutes at the end to answer those. You can drop those in the chat or in the Q&A section. And we'll get to those. But right now, I'm just going to hand over the floor to Jacob so I don't take up any of your time. Thanks for being here.
Awesome. Thank you very much. Hi, everybody. My name is Jacob Tomlinson. I'm a software engineer. I work at NVIDIA, but I've been like a long time Python open source kind of person, right? You may find me around on GitHub in various projects like Dask or some of the Kubernetes tooling or a bunch of Rapids things as well over in the NVIDIA org. But today I want to talk about like version numbering for projects. So let's start this talk with a little hypothetical. Okay, so imagine I've got this new Python package. It's the best Python package you've ever used. You love it. You're using it in all of your projects. It's like a core dependency of all of your things. And the current release version is 2.4.8. Right now, what I'm going to do is I'm going to release a new version of this package. It's 2.5.0. And I want you to just take a second and have a think about, what do you know about that change? Right? Maybe even type it in the chat, right? Say, what can you understand about the software? What has changed about the software? Is it going to impact you? Do you need to do anything? Do you need to make any changes to your code to adopt this? How confident can you be about that? So generally, a lot of people will look at this and assume, this is adding a new feature, right? It's the middle number is incremented. This is safe to adopt. I'm kind of good to go. But I think if you've been around in the Python community for a while, you might know that this maybe is a bit more treacherous than you first kind of expect. And this is because we have rules for how we do these version numbers, right? A common rule that lots of people use is this thing called semantic versioning. So if you want to make a big breaking change that's going to completely overhaul your project, you change the big number. If you want to make some kind of small backward compatible, I'm going to add a new feature, I'm going to add something orthogonal to what I'm working on, you increment the middle number. And if you're going to just fix a bug or do a security fix or some kind of problem, then you increment the small number. And one of the things that the semantic versioning spec says is that if you make a minor or a patch release, that is always backwards compatible. Anybody who is on version 2, they can adopt any newer version of version 2, and it will just work. Right? But if you've been around a while, you may know that that's not always true. Right? Things happen. People accidentally break stuff in various releases, and it's not as clear cut as saying like, oh, that was actually a major breaking change. So just to give you a little example, we can't live in this world, I guess, where we make this broader assumption, because we can't just adopt things without thinking. Right? You're going to run into some traps. There's actually quite a nice law about this, and of course an XKCD to go with it, which says that if you have any kind of significant number of users of your package, whatever you change, whatever you do as a maintainer, as a developer of that package, if you change something, you are going to break something for someone, because somebody is going to depend on every kind of observable behavior of the software, whether it's intentional or not. And Python is not particularly rigid with kind of private APIs and public APIs and things. So you find people doing all sorts of stuff, digging into if you dig into the private API, that's your own fault, right? But you can dig into the private API. I did it today. Actually, I was working on a Sphinx extension, and I ended up using an underscored named attribute of something in Sphinx and thinking, that was a bad idea. I probably shouldn't do that. But people do it because you can. So one example that I like to highlight this real kind of problem is, often when people think about software, you think about kind of the input and the output of a function or a method or whatever kind of part of the API you're exposing. People think less about exceptions, but exceptions are part of the public API of something. And just to pull an issue out of GitHub, there's a pandas example from a little while ago now, where with the pandas 2 release, if you tried to create a series of date objects, right, without the time component, you just the date objects, a series of dates. If you then try and cast that to a date time, you can change the D type to a date time, which would either kind of set the time to to midnight, or it would kind of raise a problem. The way that this was implemented in Pandas 2 was that they missed catching this case, and so it would try and convert date times to date times. It would accidentally try and read the time attribute from the date object, which it doesn't have, and it would raise an attribute error. Right? This is an internal error within Pandas that is bubbling all the way up to the user. And so in Pandas 2.0.2, they caught that error, right? Somebody opened an issue, somebody made a pull request, they caught that problem, and they re-raised the exception as a value error. That's true. That's kind of correct from in the broad sense of things, right? Before it was broken, there was a bug, and now it is fixed, and it is raising the right type of exception. But anybody that was using Pandas 2.0.1 may have run into this problem, and they may have done like a try except block and caught that attribute error and handled it themselves. And so in changing to just a tiny patch release of Pandas, their code is now broken, right? Their try except won't catch the value error, or just catch the attribute error. Maybe they've been more flexible and everything's fine, but this is just one of those examples where if a bug exists, especially if it exists for a long time, people work around things. And then when you go and fix that bug fix can be breaking for a lot of people. And I've definitely done it where I've merged code into projects where a bug fix has made things worse. So as a maintainer, as a creator of Python packages, like it's not easy to choose version numbers. It's very hard to actually be like, what should the next version of my software be? And EffVer tries to give you these kind of rules, but it kind of makes a lot of these promises around backwards compatibility that is very, very hard to actually achieve as a maintainer. Maybe if you're a well-funded project and you've got lots of time and resources and you're like a huge core project, then yes, you can do rigid EffVer, and that's great. And I'm very, very happy for you. But a lot of the projects that I work on don't have that luxury. And I think the majority of Python projects that I use don't. So what do we do instead? We don't like EffVer because we can't guarantee all of the backwards compatibility and everything. Is there another option? Well, the other thing we see is lots of people doing this, right? Projects switching over to calendar versioning. Again, I've worked on projects where we've done this, where we've just said the semantics are not helpful, right? We're confusing people, or we're breaking the promises. So we're going to switch to a different scheme. We're going to switch to using a date. The problem with this is what happens when I make a new release, right? I'm going to go from the July release to the August release of this package. Now there's just like no information in here. Right? Other than it's newer, it's bigger, it's +1. It's not giving me any information about what's going on, and that's kind of not ideal either. So lots of projects adopt this calendar versioning. Often they'll do kind of like a year for the big number, the month for the middle number, and then some projects do a day for the small number. But it's better to just have like an ever increasing number, because that allows you to do multiple releases in a day. Maybe you push a release out and then you go, oh no, actually there's a really bad bug. You need to very quickly push another release. Having an index on the end helps. But like I say, there's no information in this. And even worse, there could be like anti-information in this. If you work on a project which depends on other libraries and they all use calendar versioning, people might start making assumptions about like, oh, well, all of these libraries were released in the same month, so they must all work together. But actually, one of them was released and then it took another project like a couple of months to adopt that feature or something. You need different versions, but using something as regular as the date can often lead to more confusion. The counterexample to this that lots of people often talk to me about is Ubuntu. Right? If you're used to using Linux computers and you've used Ubuntu or many other distributions, you'll know that they use the date for their version number. And even if you go to the calver.org website, it holds up Ubuntu as this example of a big project that uses the calendar. But actually, if you look at the Ubuntu version numbers, you'll see that there's a bit of a pattern in here. Right? Ubuntu only releases once every 6 months, and sometimes it will do patch releases on those if it wants to tweak some of the things that go into it. And occasionally they'll bless some of those as this is a long-term release, and we'll do patch releases over time. But they've kind of added some information back into their pattern, right? Instead of doing just a raw calendar version of pushing the dates out, They do a release intentionally every 6 months. Those releases are not backwards compatible. They can make breaking changes in those, and then they increment the bug fix number as they kind of fix issues with that distribution. And so they've almost, you could think of it as Ubuntu has kind of smushed semantic versioning back onto calendar versioning, right? They want to give you like a major breaking number and a patch release. And so I would kind of argue that Ubuntu is not the big example that lots of people hold up. Now, I can spend a lot of time talking about calendar versioning because in Dask, we adopted calendar versioning a few years ago. There's been a whole host of challenges around doing that. I wrote a blog post about it. I don't want to kind of go off on too much of a tangent about calendar versioning. If you're interested, go and read the blog post. Now, I feel like these two schemes, I've pointed out a bunch of flaws in them, but there's like a time and a place for these. So just to kind of recap, semantic versioning is good if you really have a strong API that you have a lot of control over. You're controlling the inputs, the outputs, and the errors that are coming out of it. It's great if like you are well funded and have lots of control, and you can spend lots of time making sure that the backwards compatibility works. Maybe you want to backport bug fixes or do whatever. It's great in that kind of world, and I can see in a corporate environment maybe that's exactly what you want to use. But I think for like open source communities, especially like the one that we have around PyData, it's just not a good scheme because it tries to communicate things that it ultimately ends up failing to stick to. And so I don't think we should use semantic versioning that much within our community. Equally for calendar versioning, there's a bunch of places where using a date makes a lot of sense. Maybe you have like a bunch of configuration files. Maybe you have a model that was trained on a certain date with input data that was kind of recorded up to that date, right? Using the date to kind of timestamp models or timestamp configuration files that are constantly evolving, like that makes a lot of sense. You could also say like a distribution, a collection of a whole bunch of other packages. Maybe that's a good example for calendar versioning. It is one of the reasons actually why we adopted it in Dask, was because the main Dask library itself is kind of a wrapper around pandas and NumPy, and DaskML is like a wrapper around scikit-learn. And so we're having this conversation about, well, if NumPy makes a breaking change, or pandas makes a breaking change, or scikit-learn makes a breaking change, like, do we have to tag Dask as like breaking change all the time? Is our major number just going to increment and increment as all of the downstream projects that we're wrapping? We're almost like a distribution of these other libraries. Equally, you've got the Anaconda distribution, or CondaForge equally could be a distribution. Like, dates are good for distributions, but it's bad if you want to kind of communicate what has changed in a project to someone, unless you kind of add more semantics like Ubuntu has. So if we don't like semantic versioning and we don't like calendar versioning, is there another way? Well, actually, if you have been developing Python projects in the PyData space for a while, you might know that a lot of projects kind of do semantic versioning, but they don't follow the rules as rigidly. They have like a loose kind of informal spec around how that's done. And so kind of last year, I decided to write down like how I was doing this in my projects, right? This thing that is not quite semantic versioning. It has some slightly different rules. It's not written down anywhere. Let's write it down and give it a name. So I wrote this blog post and I gave it a name of EffVer. This is effort-based versioning. And since writing this blog post and kind of putting it out there, a whole bunch of projects have kind of stepped forward and said, we do that. Right? This kind of describes either our existing way that we make decisions about releases, or projects have come out and said that they just think it's sensible and they're going to adopt that. So projects like Matplotlib and Jupyter Hub, JAX and ZAR, and the Array API Extra repo, Microsoft Select GBM. There's a whole bunch of projects out there that have kind of officially in the documentation said that they use EffVer, effort-based versioning. So let's talk a little bit about what this scheme means. EffVer follows the same kind of pattern as semantic versioning in that you have 3 segments. In the blog post, I gave them like slightly different names. Instead of being major, minor, and patch, I called them macro, meso, and micro, just because, the PyData group tends to be a sciencey bunch. So, science words are good. But the intent here is, instead of trying to say, this is a breaking change, this is an orthogonal feature, and this is an orthogonal bug fix that are like have backward compatibility, these numbers are kind of more intended to be a signal of impact, right? trying to roughly quantify impact. You could almost think of this as like a magnitude scale, right? The big number, the first number is like, okay, this is a big impact. This is going to be disruptive. It's going to affect a lot of people. Pay attention to this. I'm skipping the slide. The middle number is, this might be some effort. There may be some impact to some people. We're kind of acknowledging that you might want some caution. You might want to read the changelog as you adopt this change. And then the micro number is intended to be like, this shouldn't impact anybody. It shouldn't affect anyone as you adopt it. Now, I was talking to Angus Hollins about this at SciPy, I think, earlier this year. Angus worked on a bunch of projects, including Jupyter and Awkward Array and MIST. And Angus correctly pointed out that version numbers are just a social contract between people. I know we can think of these as like a thing that pip or UV or Conda or Pixie or whatever. What your package manager cares about these because it has to solve the dependency tree for your environment. But really, version numbers are just a way of humans communicating to humans about what is safe and what isn't. And that's how you choose what version you put in. So as a maintainer of these libraries, you need to make a decision every time you do a release. How do you choose a new version number? How do you choose what goes into it? Now, I think one of the biggest challenges that I've seen around semantic versioning particularly is that in open source, there isn't like a plan around releases in the way that there are in other projects. Maybe there is like NumPy and scikit-learn, like big projects, but most projects are just, working at the tip of main. There's a bunch of issues. People are coming in, they're making pull requests, they're making changes to the code, maintainers are merging those in, and then at some point, a maintainer will decide to make a release. There isn't like a plan of like, oh, we'll put all the bug fixes in now and we'll do a bug fix release and we'll save all the features for later. And then, there's just everything goes into main. And then at some point you draw a line with a tag. And so at that point, maintainers have to make this decision of what should the new version number for my software be. And one of the ways that I like to think about this is partly because I come from like a weather and climate science background, is risk modeling and risk matrices. If you've not seen one of these before, go and read the Wikipedia page. It kind of gives you a good overview. But the idea is that you have this kind of two-dimensional matrix where one axis is how impactful the change will be. Is it going to be, slightly impactful? If you're talking about rain, is it going to be like, a bit of rain that's going to disrupt some people? Or is there going to be so much rain that all the houses are going to flood? And then at the other axis, you have like the likelihood. Or maybe you could think of it as like the number of people affected, right? So how bad is it going to be and how many people are going to be affected by it? Or what is the chance of people being affected by it? So if you're down in that bottom left hand corner where, there's a tiny chance that it will affect one person, that's very low risk, maybe bump up the minor number, right? Just the end number is fine. If you've added a couple of features that have changed some internal functionality and you're like, oh, okay, this shouldn't be breaking for anybody, this shouldn't be problematic, but there has been a lot of like code churn, we've done some refactoring, we've done this and that, maybe it's time to bump, to send a little bit more signal that something's going to happen. Maybe we're falling into this high or medium risk range. You bump that middle number to be like, look, there's stuff, pay attention, see what's going on. Or maybe you've intentionally changed an API, you've changed a top level API, you've removed some old deprecated APIs or something. You are going to break some people who haven't, adopted a new way of doing things or something. You have a lot of certainty around there will be impact. Right? That's the time that you bump that big number, that you go from version 2 to version 3 of your software. Right? You're just trying to communicate to people, what is the risk of taking on this new version? What is the impact going to be on you, the user? Like I, as the maintainer, I'm making the software and giving it to you, and you give me a star on GitHub to say thank you. And then I'm also trying to be respectful of your time because you're then going to take some time to integrate that into your work. Maybe you're just going to do, pip install -- upgrade, or maybe you're going to, have some CI that runs and tests some new versions of things. But there's going to be some impact based on my work. When I hit tag, it will affect some amount of people. And so the least I can do is communicate to you kind of what happens. Now, to go back to the idea that this is a human thing, right? What happens if we get this wrong? Right? The maintainers of these projects are humans. What if we put the wrong version number on something? What if I just bump the tiny number and then actually 10% of people have to do something? Like that's actually more impactful. Maybe it's that pandas change, right, that we talked about before. I've fixed a bug. It was correct. It is now, the code is now more correct than it was before. And I'm sorry to the chunk of people who had worked around that or were impacted by that bug being fixed. Maybe I've got a lot of people kind of upset about that. So let's take a little example, right? I'm at the top of main. I'm on version 2.1.1 of whatever I'm working on in EffVer. I do a new release, 2.1.2, tiny bug fix, like the pandas one. But actually, a bunch of people appear on GitHub and they open issues and they say, oh, this has broken things for me. I can't believe going from 2.1.1 to 2.1.2 has broken my whole workflow. As a maintainer, you can go, oh, I didn't expect this. I didn't intend this to happen at all. But looking back over the changes, looking back through the pull requests, like that was the correct thing to do. I don't want to roll them back. I don't want to undo the bug fix that I did. I just want to like correctly tell people what's happened. So what you can do, I mean, you can do this in basically any scheme, but this is kind of written in the EffVer spec, is that what you could do is go back, check out the working commit that everybody was happy on, and just tag that again as the next release. You can tag the same commit multiple times with multiple versions and release it. Great, push it out again. You've gone from 2.1.1 to 2.1.2, and then on to 2.1.3, and you're back to everything working. So you push that commit out, everybody upgrades again, and everything's fine. But now you still have this 2.1.2 that is correct. You just want it out there. So what you can then do is then re-tag that and increment a different segment, right? You can do 2.2.0 and just say, look, this is the new version. There is going to be some amount of impact. Here's the warning. I've bumped the middle number. Go and use this information. Or maybe it was a really big thing and you want to go to version 3. You can do kind of what you like in here. But as a maintainer, it's good to kind of let people roll forwards onto the correct thing, especially if you're kind of sticking with your course of action. Now, the other question that I get about this is, what if I add a big new feature that is truly completely orthogonal and has no impact at all on existing users? Right? Under the old scheme, you would bump the middle number to be like, here's a new feature. Under the rules of EffVer, it has no impact. So you would bump the small number, right? But that feels kind of weird. And this goes into the like human side of things. Of like, if people expect the middle number to be bumped when there is a big feature, then bump the middle number. What's the worst that could happen? The worst thing that you're doing is you're maybe overly warning people what's gonna, that this might be slightly bigger change to adopt. But maybe, you've got a cool new feature and maybe they do need to do something to adopt it. But at least this is like a positive failure case, right? By overly bumping numbers that you don't need to, you're kind of overly communicating to people, but then people may be just being slightly more cautious than they need to be. And that's probably better than the other failure mode where you're making breaking changes in minor or patch releases that are breaking people and people are upset about that. Now, in the interest of time, I might skip over this one. A lot of people talk about 0 point whatever releases, lots of projects never actually ever go to version 1, or is in this 0 point whatever. And under semantic versioning, that means like no rules apply, basically. Hennek has also got an awesome blog post about why SemVer is problematic. And one of the things he mentions in this is that if you've got the major version of 0, then it's YOLO time. You can do anything that you like. Under EffVer, maybe we're not as loose with that. We're just kind of saying, look, if the big number is 0, this is in early development. There's a lot of development going on. And maybe just take the 2 numbers as like big effort and small or no effort, right? You just kind of change that fidelity. So just to recap, lots and lots of projects in our space loosely follow semantic versioning, but actually it's better to write down what that means, right? What are we actually doing? If we're doing kind of SemVer, why don't we write down what we're truly doing? And I've tried to do that and called that EffVer, right? So EffVer communicates to people what the impact of adopting a new version of some software is. It kind of gives you a bit of a signal of like, can I just blindly adopt this? Should I read the change log? Should I plan like a month's worth of work time to adopt this? It doesn't try and differentiate between features and bugs because we put lots of things into every release. It's just trying to communicate those impacts. it's kind of got all these different things around development versions and fixing broken releases and things, which I think is helpful to this community. It gives you a bit of a playbook as a maintainer of what to do in these situations. Now, if this kind of resonates with you, if you're working on a project and you think like, oh yeah, this kind of roughly describes what I've been doing, please come along to the repo, the blog post that's linked in here. Go and open issues, have a conversation with me about like, is there any wording that you think doesn't quite capture how reality is, or is there anything you want to change in here? And if you do think this is a good fit for your project, then please do go and put a badge in your README to say you use EffVer. That lets your users know what to expect when they're adopting new versions of your software. So I'm not here to claim that this is like a brand new way of doing things. Lots of people have done this for a long time, but it now has a name and you can go and link against it. So thank you very much. And if you have any questions, please do put them in the Q&A in the chat.
Thank you so much, Jacob. Currently, I don't see any chat or questions in the chat, but we'll give it just a couple seconds to see if anybody drops any in there. All right. Well, I would encourage you all, if you think of any questions, jump over to our PyData Discord and see if you can ask questions over there, interact with other attendees and speakers. And if anything comes up, I know Jacob would be happy to have you reach out. So thank you so much for being here, and we will see you in the next session.
Thanks, everyone.